Have you ever heard of Hawking radiation from black holes? Predicted by the brilliant physicist Stephen Hawking in 1974, this radiation remains one of the universe's great mysteries, one that we have yet to observe until now. Welcome to our channel, where we explore the wonders of the universe. Today, we're talking about how scientists believe they can detect Hawking radiation from black holes using today's telescopes. Let's dive in. So, what exactly is Hawking radiation? In 1974, Stephen Hawking predicted that black holes not only absorb matter, but also emit particles with extremely high energy. However, we haven't yet directly observed this phenomenon. Imagine this: a giant black hole, known for devouring everything from light to matter, could actually emit particles. It seems contradictory, but that's the magic of quantum physics and relativity. When two massive black holes collide, or when a black hole consumes a neutron star, gravitational waves are emitted. These waves, first predicted by Einstein in 1916, were directly detected in 2016 by the LIGO system. But it's not just gravitational waves. These collisions also produce black hole morsels, smaller black holes with masses similar to asteroids. These morsels can emit high-energy gamma-ray bursts and have evaporation lifetimes that vary depending on their mass. So how can we detect these signals? A research team in Europe has shown that we can detect Hawking radiation from these black hole morsels using modern telescopes. Signals from black hole evaporation typically include photons with extremely high energy, surpassing the TeV range, tera-electron-volt. We're talking about telescopes that can detect radiation in the range of 50 GeVs to 50 TeV. This is a golden opportunity for astronomers to explore Hawking radiation. Cherenkov telescopes like HESS in Namibia, MAGIC in the Canary Islands, and Veritas in Arizona can all detect this radiation. But how do they work? When high-energy gamma rays pass through Earth's atmosphere, they create Cherenkov radiation. This is the same kind of blue light seen in nuclear reactors. By observing this blue light, scientists can detect radiation from black holes. Detecting Hawking radiation won't just help us understand black holes better, but also open up new possibilities for discoveries in physics, like supersymmetry, extra dimensions, or even new particles. If Hawking radiation is detected, it will challenge our current understanding of black holes and could lead to new theories about the universe. The research team is now reaching out to experimental scientists to begin using data from these telescopes to search for the proposed Hawking radiation. These steps could bring us closer to directly observing the phenomenon Stephen Hawking predicted nearly 50 years ago. And if this signal is indeed found, it could be a game changer in astrophysics, altering how we view the universe.